Let's solve this 2006 Aime I 1 question 9 together. So we have a geometric sequence from A1 to A12 with a common ratio r, where a and r are positive integers, so we should bear that in mind. Given that log base a of a1 plus log base a of a2 plus all the way to log base a of 12 is equal to 2006, find the number of possible ordered pairs a and r. So firstly, we can use some log rules to simplify the expression because we know that log too small. We know that log a plus log b is equal to log ab, so we can use that in our answer. So we can simplify the whole thing as log base a1 times a2 times all the way up to a12 is equal to 2006. Another thing to note that this is a geometric sequence, so a1 is equal to a2 is equal to a times r, and a3 is equal to a times r squared. So a12 is equal to a to the power of a times r to the power of 11. So we can rewrite this expression. We can rewrite this expression as in terms of a and r instead of the terms. So we have log base a times ar times ar squared times all the way up to a times r to the power of 11, which is equal to 2006. Because we have 12 terms of a, we know that there will be 12 factors of a multiplied together. And then there will be the total numbers of r is 1 plus 2 plus plus 11, which is just equal to 11 times 12 divided by 2 equal to 66. So it will be equal to r to the power of 66, which is equal to 2006. We also notice that there is an a in the base, which is kind of weird and not really useful, so we can try to simplify this because we also know the identity log base a b is equal to log b divided by log a, so this formula will be useful as well. We can write it in terms of log a to the power of 12 times r to the power of 66 is equal to log 8, which is equal to 2006. So we know that log a is equal to 2 to the power of 3. So 3 log 2, and then in a12, in this expression, a12 times 6 to the power of 66 is just equal to a to the power of 2 times 6 to the power of r to the power of 11 to the power of 6. So it will be equal to 6 log a to the power of 2 r to the power of 11, which is equal to 2006. So 2 log a squared times r to the power of 11 times log 2 is equal to 2006. And for this one, we can just bring the 2 back into the base. So we will have log base 2 times a squared r to the power of 11 equal to 1003. Thus, because we have the log rules, log a, if log base a of b is equal to c, then a to the power of c is equal to b. So we can implement this rule in it. So 2 to the power of 1003 is equal to a to the power of 2 times r to the power of 11. Then we can rewrite 2 to the power of m be A and 2 to the power of m be R. So 2 to the power of 1003 is equal to 2 to the power of 2n times 2 to the power of 2n times 2 to the power of 11m. So 2 to the power of 1003 is equal to 2 to the power of 2n plus 11m. 1003 is equal to 2n plus 11m. So now we just need to find the number of ordered pairs AR, which is equivalent to finding the number of ordered pairs of n and m, in which n and m are greater than 0. So we can try to rearrange the terms. 1003 minus 2n divided by 11 is equal to m. So we also know that we want this to be a whole number, and we also know that 91 times 11 is equal to 1001. So the largest number for m we can have is 91, because we will then have the largest possible value of m is equal to 91. That is the case when n is equal to 1. The whole expression will be 1003 minus 2 divided by 11. And then we also have the smallest possible value. The smallest possible value of m is equal to 1, which is when n is equal to 496. However, we should also notice that because this is 11 is an odd number, and then this 11 is an odd number, and then 2n is even, but then 1003 is odd. So m will be equal to an odd number minus an even number divided by an odd number, which is equal to an odd number divided by an odd number. And then odd numbers divided by odd numbers are odd. So we know that m is an odd number. So m is an integer in the closed interval 191, but m is also odd. So instead of having 92 options, we will only have the possible values of m are only odd integers. So we have 46 different values for m. So in conclusion, we will then have 46 ordered pairs. Number of ordered pairs is equal to 046. So that's it. I hope you enjoyed it, and feel free to ask any questions in the comments or to contact us with the information listed down below. Thank you.